So now we've gotten a little bit more comfortable with how to set up a single linear equation and graph that. Let's look at how we might deal with a system of equations. A system of equations, in our case, we're going to deal with two linear equations. System just means that you have more than one of those equations. So let's see how we might use that in the real world. So I went to this guy's shop to try to order some t-shirts for me and my buddies, but I didn't really like the way his prices sounded. His setup fee was good at only $10, but $15 a shirt seemed pretty steep to me. So I went to another shop, and they gave me a price of a setup fee of $30, but then he was only going to charge me $5 per shirt. And I wasn't quite sure which one was going to be the best deal. So I already have the graph of the place A, the $10 setup fee, $15 shirt, and there's the linear equation I wrote to model that. So I'm going to write a linear equation to model this one as well. So I need to figure out which is my slope and which is my y-intercept. The setup fee is $30. That's a flat fee. That's a one-time thing. So that's going to be the y-intercept. The $5 per shirt, I'm going to have to pay $5 for every shirt. That's the rate at what the cost is going to be changing. So that's going to be my slope. So y equals 5x plus 30. X is representing the number of t-shirts that I buy, because we have to multiply that by 5, because I'm paying $5 for every t-shirt, plus that one-time fee of $30. And y is going to be the output, which is the total cost. So let's go ahead and see how we graph this. So my starting point is 30. That's my y-intercept. I'll go ahead and put a point there. And then I have a slope of 5. So I'm going to go up $5 and then over 1. Could be right in there. And then I need to go over 2 and up again, which will be right in there. And I need to go over again and up, which will be right in there. So I connect these. Please don't let my lack of artistic ability skew what I'm trying to get across in this lesson. It looks like these intersect right here. And what that means to me is that the input and output, my x's and y's, are the same right there. So the cost of 2 t-shirts at the same has the same cost. 2 t-shirts at both places will be $40. If you look across, and I'm sorry, I do not draw a little bit better. The cost of 2 t-shirts is going to be $40. So if I was only going to buy 2 t-shirts, then it would not really matter where I did that at. Now, if I was only going to buy 1 t-shirt, it would be cheaper for me to go to the place graphed in blue, because 1 t-shirt is only going to cost me $25 there. And the cost of 1 t-shirt here is going to cost me $35. But once I get past 2 t-shirts, it would be much cheaper for me to go to place 2. As you can see, this is going to continue increasing at a slope of 15 to 1, and this is only going to increase at a rate of 5 to 1. So hopefully you can see how being able to develop these system of linear equations might actually be advantageous in the real world.